Hello everyone, and welcome to this new video. Today, I would like to talk for a bit about Dungeontech. Namely, I would like to create a video which kind of wraps that up, or at least addresses some things which haven't been dealt with in the past. So, first of all, I want to just talk about Dungeontech in general, and after that, I'll talk a bit about this program you can see right here normally. So, it was a bit over 2 years ago that I started with Dungeontech, you could say, by looking a bit into the code, and after a while figuring out that there was a theoretical configuration for 72 spawners inside of a single cluster. Now, since then, I've worked on this project on and off, but yeah, now it's been a while, and I'm not that interested in really expanding that on the subject too much anymore. Partially because the 72 spawner cluster seems a bit unrealistic, even if it's theoretically possible. And secondly, just because the subject doesn't interest me that much anymore. So, as a result, I thought I should still make this video, mainly because some people, mainly Yebe, have been asking me to at least publish, if I'm not going to work on this anymore, at least publish the stuff, the code I had. What code? Well, the code which gave me the 16-tuple skeleton spawner cluster, which I showed in my April Fool's video last year, which I will also link down in the description. So, with that out of the way, I think I can start talking about this program. Oh yeah, by the way, just before I continue, I'm not going to make grandiose statements about whether or not 72 spawner clusters are possible or not. Mainly this thing is just I'm not that motivated anymore. Maybe other people can continue with it and do some great stuff, but for the time being, I'm not motivated. Maybe I'll get back to it in the future, maybe I don't. I just want to publish this, and we'll see from there. Also, I believe in my last video I said something about big spawners and about creating like 16-tuple big spawners clusters. Yeah, that's not that easy actually. I realized some mistakes since then, and it turns out that I rewatched Pandas and I think Marin's videos on the subject, and I realized that there was a mistake in my reasoning, and that I would at least need, well, that would pretty much be very hard to create more than one big spawner per chunk. So, I don't know, maybe 5 cluster would be nice, maybe an 8 cluster is possible, but anything above 1 spawner per chunk seems really tough to me, if not impossible. So, just a correction there. But let's focus on this program, right? That's what this video is about. So, I'm not going to go over all the code, mainly because I wrote it a year ago and I only started looking at it again today. So I don't know what most of it, well, I don't know what all of it does, but it has a fair bit of comments, so hopefully you can help yourself a bit too. So here's the main class. This is where the program starts. Just print start program. Set some variables. Really, in here you just get your constants for your search. For example, for the video I showed, the target was 0, 128, 0. That's where the player would be standing. And then we want a skeleton spawner, so we set that to true. The other ones are still zombie spawners and spider spawners are still set to false. And then as for seeds, these are what I call the base seeds. So pretty much these are the seeds which you can... They're pretty much the internal seeds of the random object right before dungeon generation starts. Pretty much in the sense that when you set seeds to the random object in Java, then it actually XORs the value you set with a certain mask. And when you get the seed, I wrote a custom random class, I'll get to that in a second, where you can also get the seeds, and that also XORs it again. So it's technically not the internal seed, but a bit different, but it's pretty much what the internal seed looks like to the outside. So you pretty much need to enter those two. I will get a bit into how do you get these a bit later, but it's either entering them manually or recreating all of the Minecraft code, which gives you happens before dungeon generation and also as a result chunk generation. And that would take a lot of work. If you want to do that, up to you, but this is how I did it, because I just wanted to try some specific positions. So yeah, right here, chunk coordinates, and every time the matching base seed, right before dungeon generation starts. So that's all the constants pretty much, and then it just creates a search object with all of those values, and it starts to search. So I guess that means it's probably good to get to the search class. Now here's the header. Don't think there's too much to see here, just some structs mostly. Oh yeah, I should probably say that this is written in C++ for anyone who didn't notice by now. I don't know that much about C++ either. I still have a lot of problems writing it. This is my first program I wrote in C++. I wrote a second one since then, but I still kind of suck at it. So yeah, if there's some bad code in here, yeah. I wouldn't say I'm aware, but I can live with that. But yeah, there's not too much to see in the header, I think. So let's go to the actual class itself. Now this is really the central class of the program. That's why I have two enters right here. Bam. So constructor, nothing too fancy, just initializes a bunch of memory of variables which define the search, right? Round 16, just a simple method for some arithmetic. Save block, again, just a simple method to which I use to save coordinates to files. That's for the output, of course. I'm not entirely sure what I need. Oh yeah, see, I used that here because I need lots of different blocks apparently. Okay, so I'm still surprised. Oh, whatever. I'll get to that in a second. Then the search. Search for dungeons in a 3x3 chunk region. So that here we have what we call the chunk factor. So those are the relative directions on the chunk coordinates compared to I guess the chunk with the highest coordinates. Now you notice that there's 4 things crossed out right here. Well, those are the coordinate chunks. If you want to get into the details why those are crossed out, you should probably watch the 16-tuple spawner explanation video I made last year. However, the main thing is just that corner chunks only have very few positions which are valid for spawning, and in the configuration I was using, it didn't even matter, so I disabled them because it's better to search. Oh yeah, also probably there's one thing I forgot to mention about the constants you send through, the values you send through. Maximum branching factor, that just limits the search tree for a bit, because as I mentioned in the last video, there's a lot of states which come back after a while, or I'm not even mentioning them, but I'm mentioning it now. Yeah, because just calling random int a bunch of times means, if you add 10 floor blocks in one dungeon and 0 in the next one, you're still gonna get the same block after that than as if compared to the case where you would have 0 floor blocks in the first dungeon, 10 floor blocks in the second dungeon. So as a result, there's a lot of cycles in your search tree, and limiting the branching factor seemed to work alright, as in it didn't really limit the results too much, but it really increased the search time by quite a bit. So that's what the maximal branching factor is. It's just a constant I came up with. So let's continue over here. Start chunks, just a little print. Now, oh yeah, seed caches, I'll get to that in a second. These are things I was working on back when I abandoned the project. This was after the video. Dungeons. Those are just setting some pointers right, I believe. I'm not that sure actually. Anyway. Let's see. So yeah, this is where the real search starts. Also, where are the seeds? Here, this is where we get seeds. So this is where I get to show the seeds constructor, or the seeds class, or whatever you want to call it. So yeah, here, little header, nothing too interesting. Now this class isn't too interesting either. It just gets seeds using linear search based on that list I defined earlier. Now, I mainly just made it in case I at one point want to recreate the full population algorithm and that kind of stuff. But so yeah, if you want to do that, that's up to you. then you could probably put out a ton of code in this class, but for the time being, it's mostly just an empty class. So it gets the seeds, and it starts a search. And now I really will have to start skipping through some stuff, or else this video is going to take an hour. But yeah, it's pretty much just recursive search. There's two methods which are being used here: chunk search start and chunk search middle. Start starts at a different phase, I believe. Yeah, it starts at the positioning phase, and the chunk search middle, which is used for the other layers, starts at the floor phase. And there was some reasoning behind this, why it was best structured that way, or best. Why it wasn't... Of course, I wanted to use one recursive function, but in the end it turned out to be quite annoying to do it that way, so I ended up splitting up the layers in such a way that we just have... The beginning is a bit weird, but after that it's all recursive. And yeah, I'm not gonna get too much into the details. Let's just mention some basic stuff, like we have branch and bound. If you don't know what it is, I can send you Wikipedia. To Wikipedia. Let me look it up. There should be a Wikipedia page on this. Yeah, it's a certain optimization strategy for search problems, where you pretty much just cut off search branches once you know that they cannot improve the optimal solution anymore. In this case, for example, say you are 5 levels deep, so you can only generate 3 more valid dungeons. You still need to generate 5 to get to the optimal solution, then you know that this branch is useless and you might as well cut it. Now, if it doesn't get cut off by the end, that means that it is optimal, I believe. And then it stores the optimal solution. That's up here, not too interesting. Just little thing right here. At the end, there could still be excess dungeons. So you can, those get removed automatically because they don't add anything to the solution and technically make the problem a bit more constrained for the other chunks. Yeah, I'm not going to get into all the details right here. Now, chunk search middle is a real chunk searching algorithm, which is a bit more complicated because also here, this is where the you can start getting some options. So yeah, right here it goes through the different floor counts and checks what the benefits of them are, and it arranges them based on priorities. Now, I don't exactly understand how the priorities work. I think that's something to do with the size, probably, as well as whether or not it's a valid dungeon, a valid spawner. Yeah, you can see some stuff right here. There were 6 priorities, apparently, but if you want to get into the details, well, I guess whether or not it's upper 3 or lower 3 is based on whether or not it's a valid dungeon and valid spawner. Then possible position, whether or not it's a possible position. That seems kind of important too, but okay. Apparently it's not that important, according to my past self. And then combining possible position with valid pos is also worth 1, apparently. Don't ask me. I probably had some decent reasoning for this back in the day, but now I don't know it anymore. So anyway, right here we just go through all different options for floor counts. And we handle change generation, and we just try and we check what the new positions are going to be if we were to generate this many floor position, that many floor blocks. And this right here covers the multi-cobblestone generation. Now here, use the priority from here pretty much to kind of do a bit of a heuristic search, you could say, where it in the end this whole thing is mostly depth first. So I'll get to that in a second. But at this point it's kind of heuristic, in the sense that it tries to try the most promising branches first, and with branch and bound, that also that should speed up the search for a bit. It also limits the amount of branches it takes. Technically, that makes it a non-optimal search, I guess, but it just worked out fairly well in practice, so it wasn't a real problem. And then there's some stuff like, for example, it adds a cuboid at the beginning when it starts generating, then at the end it removes it again because the recursive calls will use this data structure. Cuboids, I believe, just define the spaces which dungeons take up. So they're just collision boxes, really, whereas the dungeons also include details about how many floor blocks there should be, the position, the size, that kind of stuff, which you need to for generation. So yeah, pretty much whenever you do recursive calls, you want the dungeon and cuboids lists to be up to date because they are used by the other layers. And pretty much whenever you get an optimal solution, the store optimal method will store whatever the current thing is in a new it will It'll put it into there, and I think it will copy it. I know, it should create a copy. I don't know. It worked back then. I'm only going to hope that I didn't introduce any bugs since my edits. If I did, well, good luck fixing them, guys. Because I know as little about this as you. And yeah, also if even it tries the 10 best priority floor count options, and then it also just tries another bench where it doesn't generate the dungeon at all, where it just skips the dungeon and tries to see if the next one is a bit more, well, nice, I guess. So yeah, that covers chunk search milk, chunk search start, kind of, store optimal, valid spawner, yeah, just a simple method, which I guess saves me some code down the line. Valid position, same thing, just checks if the position is in range. Possible position, checks if it doesn't overlap with any cuboids. Maybe you can do some nice computational geometry here to make this more quicker. Right now it's just a linear search. It's just a brute naive approach, really. Get position. Yeah, pretty much gets the position for the next dungeon, given the current random object, I believe. Current X, current Z. Now I don't know what those things are, but okay. Oh, the current X, current Z of the dungeon, of a chunk where you're generating, of course. Pretty much once all that is done, it goes to the next chunk, and it just keeps on iterating through this loop until it's finished with all chunks. See? Single chunk, all chunks. And then it starts saving. Right now I have this thing set up here. You probably want to change this. Or else it's going to create a bunch of folders. And even though if there's no works on Windows, I use different path names, right? But yeah, this is just something I used to quickly get the configuration into my world. I had a filter which automatically generates these blocks pretty much at the right position. So this just pretty much created a Python file with this, and then just a big list, well, technically a tuple of tuples, and each tuple is a coordinate or something. Yeah, something like that. Let me see if I can get that up here. You know what, I should probably show it too. I'm going to quickly see how I still have it around here. Block placer. I mean, I still have the data, but I'm looking for the filter which generated. It's probably part of my randomness 1.0 filter, I'm afraid. Yeah. Place blocks. Yeah, indeed. It's just part of random 1.0 filter, which I don't want published because it's kind of personal. But if you want the code, it's like literally just a couple of lines. So yeah, I would say we're alright. This is what I use to get it. I'll just quickly paste the code into here. So yeah, just write that, change this, and I guess it should be good. That's Python code, of course. So that's the kind of code you would use in an empty edit filter if you want to automatically generate the blocks. There. All right. And that just generates a nice file which allows me to easily generate the blocks, and that's about it. So that's the search seed main class. What else is there to cover? I guess next thing I'll talk about is random. This is the random class. This is a pretty much a port of the Java random class. Documentation is based on these things. It's class based on documentation, which I found here. It's fairly hard to find documentation which actually also talks about the internal workings, but it's there. Now, the Java random class is a linear congruential generator, which pretty much means that whenever you want some random something, it just gets random bits. This function right here returns 32 random bits, and it gets those by pretty much getting, I think, the last 48 bits from the seed, it seems. Yeah, looks like it. 48. Oh, actually, no, this one can also give you other amounts, but pretty much it generates 48 random bits and it gives you whatever amount you need from there. Don't ask me what happens when you try to ask for more than 48 bits, but okay. So, pretty much linear congruential generator, what it does is every step it multiplies multiplies seed by a certain constant and adds a certain constant. Of course, and then of course everything is done in modular manner. So right here, we just remove all of the excess stuff. And pretty much that's how a congruential generator works. All of these other methods, like next in, next long, next float, next double, they all just call get a bunch of bits. That's all really. So, and you can even get some other stuff like next Gaussian is in the original Java class. You could even do stuff like next string, like just you have a bunch of random bits and you throw them to ASCII, but of course that will give you won't give you very useful characters most of the time. Anyway, you could do that. So I don't think there's too much more to talk about here. Search, yeah, just some header files. Hash table is not written by me, but by Maarten Baert. Here's his website. He gave it to me because in certain regards it's better than the default C++ annotated map. Apparently the annotated map is written in a very general way, which usually isn't necessary. And it can be optimized a bit, apparently. But I don't know the details. Either way, I needed it for an optimization I was working on using seed caching. But I'll get into that later. So I should probably get back to my script because this is already taking way too long. Right, I think we've talked about the code. Oh yeah, depth first search. I quickly want to mention that just as I guess a rough summary of how the search works. It's depth first. So pretty much you go deeper and deeper into branches. It's not like A star where you switch branches constantly. Because branch and bounds to do some optimizations, and then also as an optimization we use a maximal branching factor, even though that does technically remove optimality. And I think those are the main things you need to know about the search methods. Now, some other stuff, because this video is getting long. How to find the base seeds, of course. So for that, let me get Eclipse. Here we go. Now, that should whatever. What I was trying to say is Mojang is really annoying in terms of how they protect their code. You know, they have obfuscation and all that kind of stuff. They still have closed source, even though the clients got cracked fairly quickly, as far as I know, whenever they release them. But yeah, technically, if you want to comply by Mojang's terms, you can't release this kind of source code. So I'd have to compile it and obfuscate it, and I can't even get the compilation working. I've had problems with MCP in the past. So I'm not going to do any of that. So you guys are going to have a bit of a tough time, but yeah. Sorry, but if you want to do Dungeontech, you're going to have to get into nitty-gritty bits anyway for a bit. So, how do you get those base seeds? Well, the way I got them is just by writing a custom random class. I will include this one because, as far as I know, I wrote this myself. So, they can't really complain. Mojang can't complain about anything. This is based on Oracle's code. And I don't think Oracle will complain much either because this is publicly available. Yeah, so I will include this in the description. You just put it somewhere. You import it in this class called chunk provider generate, which is somewhere down here in Net Minecraft World Gen, I believe. Yep. This part includes the population code, line 401. Oh yeah, this is a Minecraft 1.8 code. My solution for the video from over a year ago also worked in 1.9. No promises about 1.10, 11, 12, or 13, which is upcoming. Good luck. And again, I'm just publishing this code and giving you some information about it. This is not supposed to be some great tool which everyone can now use for Dungeontech. That being said, I haven't heard of many changes, so with a bit of luck, it still works. Even if you're unlucky, it still probably works with some changes. So anyway, you want to go to the population part. Actually, there's some things you want to change up there too. Pretty much the random object, I replace it by a pop random object, which is a custom random object. Custom random, as you may notice, extends the random class. So we can pretty much just use it for everything we used to. But there's one main method which is new in here. This, get seed. We need this, of course, to get the base seed at the right time. So let's go down and see if we can get that. Alright. So here we set we just pretty much do everything the same way it's done normally. Set it to the world seeds, do stuff with the chunk coordinates, set it to those chunk seeds, yeah, that kind of stuff. Stuff which happens here, blah, blah, blah. This is what you want to look for. This block right here does a dungeon generation. Of course, it calls a method for that. It's not actually this short. This does a lava lake generation, this does a water lake generation, this does other structures. So pretty much what you want to do is in between lava lake generation and dungeon generation, you want to have this. This part right here is not really that important. But this right here, as you can, I guess you can just tell. I should also have a tab here. As you can tell, we just check if the chunk coordinates are correct. In my case, I was looking for chunks for around the 0, point, so this works. And pretty much whenever it populates a chunk with one of those coordinates, it just prints out the coordinate in the terminal, the console right here, and it also puts a seed right next to it. So pretty much that's what you use right here. That's how you get these seeds. Alright, so that should work, I guess. I think that covers it. So yeah, just download this in the description. I should include the download link for this. You know what, I'll probably just put all of this into a big zip together with the C++ code and everything else which you need. And you can put this in whatever folder you want. You just make sure to import it here, get the seeds, and that way you can get your base seeds. Now, I think that covers that, so let's get back to the C++ code. All I kind of wanted to talk about now is just some possible improvements you guys may want to do, if anyone's still interested in this. First one, a state cache, or I used to call the seed cache. Doesn't really matter too much. As I said earlier, the search tree isn't as much of as a tree as it is a graph with cycles, because there's lots of ways to get to the same state or a very similar state you were already in earlier. And of course, you're doing lots of work twice, or more than twice, in fact, if you don't check for that. Now, something I was working on but didn't complete was cached seeds, where you would pretty much try to cache the entire... well, I just thought about caching the seed, but actually you need to do more than that. You need to cache the entire state, pretty much, of the search if you want to be optimal. And then if you ever end up in the same state again, you can skip it. Of course, if you want to go suboptimal, you can also just go with the seeds and say it's fine if the state is similar. Then I don't care either. Now that's one thing you could do. Another thing, of course, is modernization options. For this, I probably want to show you the chest class. Again, I don't know how this works. It's just a header with some stuff, and the source file with some more stuff. And I was porting some stuff from certain Java classes. I don't know exactly which ones. If you're interested, just search for this using grep -r if you're on Linux. If you're on Windows, I don't know. And you'll probably find the right class. So this is from the Java source code, and I was porting this, trying to get the chat generation to work, but it was a lot of stuff, especially the enchantment code got quite complex, so that's pretty much where I stopped. But if you want to, you can expand on that. I will include this in the code, which I will release. What else? Base seed calculation. Of course, another improvement you could make is to do all of the Minecraft chunk population and chunk generation code, or most of it at least, in C++. And yeah, then you won't need to mod Minecraft and to get your base seeds and such. You can just have the program generate it automatically and go through different positions and all that kind of stuff. And then the last one I came up with is just optimizing the code, because I never really benchmarked this. So yeah, I'm sorry. This may even be slower than the Java code. I don't know. Back in the day, I thought that Java was actually really slow because it's just a virtual machine where every instruction was pretty much interpreted. So when it add stuff, you would then we have to go to the virtual machine and end up being multiple CPU instructions. But apparently it doesn't work that way. Apparently it is fairly optimized in the sense that it is actually a compiled language, you know. When you do an addition, it's just an addition in your CPU as far as I know. Perhaps with, well, I don't know. It's fairly quick for normal calculations. The main optimization which you can do by going lower level, as far as I know, is memory. Because Java has automatic memory management and it's not optimal. However, I never really... I'm not good with C++, and I never really cared too much about it. I just cared about it working. So, yeah, there's a decent chance it's not even that quick. So, if you want to deal with that, that's also something you could look into. Anyway, I think that's about it. Hopefully this video wasn't too long. I had a script, but it was just some rough stuff I wanted to cover. But yeah, I think I should cover all the details. Maybe there's still some stuff I forgot. If there's some vague stuff, make sure to leave a comment, and I will get back to that. And yeah, I guess that's it. So, thanks for watching. I hope you liked this video. Even if you didn't, please leave a rating, and I hope I will see you in another video. PS, I actually forgot to run my program, so here we go. Bam. So as you can tell, it's pretty fast. I think it takes like 9 seconds or something to find all the dungeons. I know, it gives you like a 17 spawner cluster or something. It is a configuration from last year. I don't know why it says 17 instead of 16. It's a long time ago. Anyways, as you can tell, pretty fast. Yay. Also, HelVince, sorry if these things were private, but really you can't even get the world seed with this, so I think you should be alright. You probably can't get the world seed, I'm not sure. But yeah, he was a little motivated to me first. So link to this channel down in the description. And that's it, I guess now really, bye.